Okay, so now we are going to use the quadratic formula. This is the other alternative to solving by factoring. So anything that we can solve by factoring, we can actually solve by quadratic formula. You'll notice that this first example is actually one of the examples that we went through when we were solving by factoring. So I want to show you that again, it doesn't matter which method you use, you're going to get the same answer either way. It's just a preference on your part. First of all, again, it has to be equal to 0. Remember what we talked about when we said solving by factoring? The same thing is true for the quadratic formula. The next thing I want you guys to do is I actually want you to pick out your a, b, and c. So remember, your a, b, and c are only numbers. So a is the number in front of x squared, which in this case is 1. B is the number in front of your x, which in this case is 5. C is the number in front of your, or is your constant, excuse me, which is 4. So now we are going to plug this into our quadratic formula. If you need to, you can rewrite your quadratic formula here off to the side. It's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And guys, you need to start working on memorizing that formula. When you take your midterm and your final, you will not have access to this formula. Therefore, you do need to remember it. One way you can do that is to write it down every time you use it. It works really well. Or you can sing it. I will post a video up on here of this song, this being sang, the quadratic formula being sang. Alright, so let's plug in. Now, one of the things you can do, instead of saying negative b here, one of the things I really like to tell people to say, because it can get kind of confusing, is you're actually doing your opposite b. Oops, excuse me. There we go. Pull that down just a second. So this is actually opposite of your b. So in this case, my b is 5. So the opposite of my b would be negative 5. So I'm going to have x equals negative 5 plus or minus a big old square root here. So now I'm going to have b squared, so that is going to be 5 squared minus 4. Remember, it is always 4. And then I'm going to do times a, which is 1, and times c, which is also 4. All over, make sure when you do the all over, you are including that negative 5 in this. 2 times a, which is 1. So technically, that's my answer. But we got a lot of simplification to do before we can actually say we're done. So the next thing we want to do is we actually want to work on the inside here, getting this down to one number. So we're going to have negative 5 plus or minus the square root. So 5 squared is 25. And then we're going to do negative 4 times 1, which is negative 4. And negative 4 times 4, which is going to give us a negative 16. Over 2 times 1, which is 2. So again, we're still trying to get this down to one number here. So we're going to do 25 minus 16. So that's going to give us negative 5 plus or minus the square root of 9 over 2. Now hopefully from what we just talked about, you'll recognize that 9 as a perfect square, so we can actually take the square root of that. And that is going to end up being negative 5 plus or minus 3 over 2. Now remember, when you take the square root of 9 and you say the answer is 3, notice I did not write the square root of 3. The square root of 9 is just the number 3. Okay, now because we were able to take the square root of that, we need to go ahead and break this into two problems because of that plus or minus right there. So we need to say negative 5 plus 3 divided by 2. And we also need to do negative 5 minus 3 divided by 2. So up here, if we do negative 5 plus 3, that is going to give us a negative 2 divided by 2. That is going to reduce down to negative 1. So one of our answers is that x is equal to negative 1. Here we're going to do the same thing. Negative 5 minus 3, that's going to give us negative 8 divided by 2. That's going to give us negative 4. So our second answer is x equal to negative 4. So these are our two distinct answers we got from using the quadratic formula. Now, hopefully, if you go back and look at our notes from the factoring section, you'll notice that we did this exact same problem and we got x equal to -1 and x equal to -4. Took a little bit longer when we did the quadratic formula because of all the simplification we had to go through to get there. But you still get the same answer. So again, you get to choose how you want to solve these problems. If you want to do solve by factoring, solve by the quadratic formula. Okay. So let's look at the second one. Again, we're still solving by the quadratic formula. It is actually equal to 0 again, so we don't have to worry about that. If we need to, we can come over here to the side and write our quadratic formula one more time, making sure we have that memorized again. Remember, you do need to have the quadratic formula memorized. So we've got -b plus or minus the square root of b squared minus 4ac over 2a. Coming over here again, writing down our a, b, and c. Now remember, our a, b, and c should always only ever be numbers, no variables. So for instance, our a for our first one is going to be a -1. Our b is going to be a +4. And c is going to be a +6. Okay, so now we get to plug these three values into our quadratic formula. So we have x equals -b or opposite b, so that would be a -4 plus or minus the square root of 4 squared minus 4 times -1 times a +6 divided by 2 times -1. Okay, so now we're going to have -4 plus or minus. We're going to work on simplifying down inside of that root. So we're going to have 4 squared, which is 16. We're going to do -4 times -1, which will give us a +4. And then +4 times 6, which would be a +24 over -2. So now we want to add 16 and 24. So we get -4 plus or minus the square root. So that would give us a +40 over -2. Now here's where the first problem and this one are going to kind of deviate from each other. On the first problem, we had a square root of 9, which we could take. That was 3. But we can't take the square root of 40. So all we can do on this guy is actually reduce him down like we were doing with our square roots earlier. So what we want to do is break him apart. So we could say this is 4 times 10. 4 is 2 times 2. 10 is 2 times 5, and just like earlier, I don't want to talk about those 4 and the 10. I only want to talk about the prime numbers. So we do have a pair of 2's. That pair of 2's is going to come out here right in front of our square root. And then the 2 and the 5 here are going to multiply back together and stay inside of our root. So we're going to end up with -4 plus or minus, we're going to get that 2 out, square root, again we're going to multiply the leftovers back together, so 5 times 2 would be 10 over -2. Now we need to reduce this. Hopefully you can see that if we look from the 4 to the -2 and we look from the 2 and the -2, that all three of these have the same number in common. In fact, they're all divisible by -2. So what we're going to do is actually divide this -2 into both of these guys. So when we do -4 divided by -2, that is going to give us a +2. Plus or minus. Now, because of the plus or minus, we actually don't really need to concern ourselves too much with the negative when we're doing this second division. We just need to say that 2 divided by 2 would give us 1. So that would be the square root of 10. So this is both of our answers. And if you need to see them separated, it would be 2 plus the square root of 10. And then the second one would be 2 minus the square root of 10.